Hello students, today we are solving a question on moving charges and magnetism. This question has appeared in the 21st January shift 2 of JEE Mains 2026. I am reading the question. An infinitely long straight wire carrying current I is bent in a planar shape as shown in the diagram. The radius of the circular part is small r. The magnetic field at the center of the circular loop is. So you can see that there are two planar parts, a straight line, and one planar part is in circular shape. So we need to find the magnetic field at this point O. So to solve this question, you first need to determine the direction of magnetic field. You see, we will use the right hand thumb rule. We'll stretch our thumb in the direction of the current and check in which direction does the finger curl. So if I stretch the thumb in the direction of current and check the direction of curling of fingers, due to this current, my finger curl outside the board. Outside the board is indicated by the diagram direction of I cap. Similarly, for this current also, the net magnetic field is pointing outside the board. However, if you curl your fingers in the direction of this current at O, you will see that the fingers will curl into the board. So, due to the straight parts, the magnetic field is outside the board, and due to the circular part, the magnetic field is into the board. So, therefore, now we know the direction due to all the three parts. Let us talk about the magnitude of magnetic field. Due to the straight part, the magnetic field formula is going to be mu naught I divided by 4 pi d into sine alpha plus sine beta. This is the magnetic field due to any straight current carrying conductor which is subtending an alpha and beta angle with respect to the perpendicular. Right? In our case, what we have a semi-infinite wire. Means its this end is subtending 0 degree and the other end is subtending nearly 90 degree. So alpha is equal to 0 degree and beta is equal to 90 degree. And then we can also use magnetic field due to the circular part. This is due to the straight part we'll call B1 and due to the circular part we'll call B2. We can use the formula mu naught I by 4 pi r into theta, where theta is the angle subtended by the arc at its center. So we have the magnetic field due to the straight part and the magnetic field due to the curve part. This is due to the straight part and this is due to the curve part. So now what we can do is we can use these formulas. So we will write B net will be equal to 2B1 vector plus B2 vector. B1 is due to the straight part, so 2 times mu naught I divided by 4 pi d. If you look at this point, its perpendicular distance from the straight part is also r itself. So mu naught I by 4 pi r into sine alpha is 0 degree and beta is 90 degree, and due to both the straight part, we said that the magnetic field is outside the board, so plus I cap. Plus, due to the circular part, it is mu naught I by 4 pi r, and since we have a full circle, it subtends an angle of 2 pi into the magnetic field due to the circular part. If you curl your fingers and see, the magnetic field is into the board, so minus I cap. This will be equal to mu naught I by 2 pi r minus mu naught I by 2r, entire thing into I cap. So what can be taken out further? We can further take mu naught I by 2 pi r out and we will be left with 1 minus pi I cap. 1 minus pi is a negative number, so better to write it as minus mu naught I by 2 pi r into pi minus 1 I cap. We'll search for either this or this in the option. We can see option C matches or option 3 matches.